there's certain definition about domain and range. If you remember when we talked about function probably a few years ago, we understand there's a certain function. For every function, you will have an input and output, right? And input is certain values that you put in the box, and then function is basically like a machine producing things and put it out. That's called output. Now, so hence there's two terms related to input and output. For input, there are certain amount of things that you can put in, right? And so hence for that case, and that's called domain, right? So domain is for defining what things you put in. Yeah, basically it's the range of input. But when you define what is output going to be, there is a range. So two words going to be, number one, domain is describing what things you can select from for input, and range is defining what things going to be for output, right? What's the range that you have? There's one thing actually, if you're confused about this, when you do shooting, somehow you understand the bullets will end up in somewhere, right? That's called range, right? How far you can shoot. So hence, basically, how far you can shoot is the output, okay? That's output. So that's somehow clarify that. So domain is for input, range is for output. So hence over here, I'm talking about the domain I'm drawing is between 0 to 2 pi. Okay, so which means the input is from 0 to 2 pi, is for the x value. Now, if we understand over here, tan x looks like this, and the other side of the equation, that's equals to 1, right? So I can actually draw it out. If I draw it correctly, that should be around here. I'm not drawing that in a good scale, but it's understandable what's going on here. So if I change the color, so y equals to 1 should be around here. Okay, now this is y, and this is x. So far so good, guys? Mm-hmm. So the first solution that we had over here, 45 degree or pi over 4, is talking about this part.
Mr. Ming.
Yep.
Can you please let in my other account just so I can watch it on my laptop rather than my phone?
Sure, sorry, I wasn't watching that one. Yeah.
Thank you.
Yep, cool. Okay, all right, let's continue over here. Feel free to stretch, and you do have your own space, unlike in the classroom. Okay, so this one is one solution we're talking about, but we do understand, you can see over here, the curve or the graph actually keep going, right? So hence we now understand there are actually more than one solution. It can be this solution as well, right? It can be, if you keep drawing over here, you have another solution over here, and you understand on the other side, you have another solution, okay? So how can we actually describe this? How can we actually describe this? So my drawing is slightly out, but I'm actually bringing in this one so that you can see clearly what's going on, just in case my drawing is not justifying what's going on there. So I'm going to use decimals so that you can see what's going on there. I'm not sure why that one's always on screen. Okay, for decimals, I'm drawing y equals to 10x for the green curve, and y equals to 1. So that gives me an equation. So based on the function that we discussed in the last lesson, you can use graphic calculator and find out the point of intersection will be the solution, right? So hence, if I actually copy this down over there, just give me a second. All right, that's basically a 10 over there. Okay, so this is pretty accurate. We understand this part will be a solution. One thing difficult to see is it's not actually giving in terms of pi or 2 pi, so hence I can draw it out. So basically over here we have pi. Oops. Now when we have halfway around here, which is 1.7 something, and then we have asymptote. Oops, everything come out. That's not too good. And for this case, that will be 2 pi. and that'll be another asymptote. So we understand there is one solution over here. There's another solution, and they're actually unlimited solutions. Okay, we want to find out how can we actually generalize this and put into a formula. If you have a look on page 16 from your workbook, you can see on the bottom right corner, you can see there's the general solutions over there, right? I'm going to explain to you why for the second last line over here, if tan theta equals to tan alpha, and then there is a general solution over there. Why is so? Okay, so have a look at the screen over here. Come back. Now we understand over here it give us pi over 4. Okay. Now what is the period of 10x? We know the period over here is really pi. Yep. So for every pi, it repeats itself. Yep. For every pi. So hence we can say, okay, from here to here is one period. You're going up and going down over here. And then you have another period from pi to 2 pi. Okay, that's one period is pi. So hence, where is this point then? Where is this point? Now, if we say this is 0 over here, and then the solution is pi over 4, can you see the next solution is basically pi at pi over 4? Yep. Because you start from the where is the graph and intercept with y-axis, with the x-axis, right? So start from here, you go pi over 4. So for this one, we have one solution. The first one is pi over 4. The second one is pi plus pi over 4. You agree for that one? And for the next one is, what is it going to be? 2 pi plus pi over 4. Excellent. Yep. You can see it's keep going over there, right? So if I actually generalize this, and it should be for the first one is really 0 pi plus pi over 4. Okay, so that we can put into a formula. Now, we can see a 0 over there is basically 1, and over here is 2. So we can say, okay, the general solution x should be equals to n pi plus pi over 4. And where n is belong to an integer. Okay, this just means integer. Okay, you can write down words over there, or you can write down a big Z, right? Z basically a German word, and that's how actually it was defined. So you can write down as big Z, or n is really belong to an integer, right? As an integer. So which means it's going to be either 0, 1, and 2, and blah, blah, positive, or -1 and -2 and infinite, either way, right? So this will be a general form for this equation when we have 10x equals to 1. Okay, does it make sense? Now, so now if we actually move on slightly over here, I might just use this space so that will be clearer. All right, if I have 10x equals to 10 alpha, where alpha is only one solution, right? Alpha is only one solution. So this is one of the solutions, right? So hence I can really replace this pi over 4, which is also one solution, right? It gives me only one solution. So hence if I replace this, if I put that into general form, x should be equals to n pi plus alpha, okay? Where n belong to an integer, right? It's integer. Okay, so this is actually for this trig equation, 10x equals to 10 alpha, and x is going to be equals to n pi plus alpha. All right, let's have one example. Just make sure that you understand what's going on here. Let me actually. So if you turn to page 19, I might use this one. Actually, I might not. I might just leave to you for this case. But I'm gonna give you one example, right? So for example, 10 x equals to, let me choose a special one, equals to square root of 3 over 3. All right. So what is x going to be? We want to find out general equation. Sorry, general solution, right? What is general solution is going to be? So for that case, we're going to find out one solution. What is one solution first? Okay. So you can use a calculator to find out what is the inverse 10 square root of 3 over 3. Now, let me actually go to the calculator over here. Can you see the calculator?
No.
You can't. It's on the screen over here. Can you see it?
Yeah.
Oh, sorry. Where's more? Can you see it now, the calculator? Can you see a calculator?
Yeah.
Yeah.
Okay, yeah, cool. Now, exactly, no, this calculator is slightly different, but it's probably a similar function as you have. So we're going to do an inverse, inverse in bracket, this is square root, yeah, where's the square root thing over there? Square root of 3, divided by 3, and bracket, right? They give you quite a nice number over there. But if you turn this into pi, it should be actually pi over 6, which is 30 degrees. So think about this and come back to B. So if this is 0. This is radians, right? It's radians. How many pi is going to be? 1 pi. How do you figure out? Let's try to find it. Pi is 3.14 or something, right? If you divide by 6, they give you the roughly same number. So hence over here, although you can't really see pi over 6, you can write down 0. That's fine. 0.52, that's fine. Okay, that's all good. Yep, if you write down 0.52, that's all good. So you don't have to write down pi over 6. I might just stick to this one because you got this one already, right? X equals to 0.52. Does that make sense? All right, this is one solution. We do understand it's going on forever like this. So this is only give me one solution over here. Now, for the next period, you will have another solution over here, right? So you're gonna add pi. And continually, for next period, you will have another solution over here. So you add another pi. So hence the general solution will be n pi and plus 0.52, where n is the integer. That's actually z, right? N is integer. Does it make sense? Yep. So just have a look. When n is equal to 0, you will have x equals 0.52. Right? That's the first solution that we have. That's one solution. A tick. Now, when n is equals to 1, you will have pi plus that part, right? So that's pi, which is 3.14. So you have 3.66, which is pi plus 0.52. So pi is 3.14, right? So you plus 0.52. So hence is you have unlimited solution over here. When n equals to 2, you can also go the other way, right? When n equals -1, you have another solution on the left side. So there is unlimited solution. Okay, so this is how you find the general solution for 10, all right? Now, since we do have double periods, I won't give you time to do exercise. Normally we do in the class, but as I mentioned, the things will be posted online so that you can see, catch up, have a look at the video by yourself. So that's all good, all right? So I'm gonna